This is Math 139, Unit 3, Section 3. The next thing we're going to do with our rational expressions is compute things with them, do operations like add, subtract, multiply, and divide. Everything that we do with our operations on algebraic fractions corresponds to what you already know about operations on numerical fractions. So I'd like to start by reminding you, if you have a numerical fraction multiplication problem, usually what you do is reduce first. Right? Looking at this one, you probably would have said, I can divide a 5 out of both of those and reduce here. And I can divide a 4 out of both of these and reduce here. So we take advantage of the fact that it's a product, factors, to reduce first. And then once we're fully reduced, we multiply straight across. 1 times 3 is 3, and 2 times 5 is 10. We'll be looking at a very similar process with algebraic fractions. We'll have to have everything in its factored form so that we do have multipliers. And once we do, we can reduce our factors before we try to multiply. Division is really just one step away from being multiplication, right? To divide, you invert and multiply, or multiply by the reciprocal. In this particular case, you would have taken that 14/15 and then changed to multiply by, and here's the reciprocal, 20 over 21. Once it's changed to multiplication, the process is exactly the same as it was over here, right? You would have just looked at this and said, I can divide a 7 out of the 14 and the 21. And then the 15 and the 20 are both divisible by 5. And once you're in the reduced form, multiply straight across, 8 over 9. All right, I know you all know how to multiply and divide regular numerical fractions, but again, this quick review, I want you to keep in mind, gives us the same process that we'll use with the algebraic ones. So starting in the first example, which is multiplication, I'd like to begin by saying, is there anything I could reduce first? And the answer is maybe, but I really need the factored forms before I do anything else. So let's get our factored forms. We have 20 over x to the 6th. And in the denominator, I could factor out a 7 and make that x minus 2. In my second fraction, in the numerator, I could factor out a 2 and make that x minus 2. And then the bottom is 50x squared. All right, where can we reduce? Well, first of all, I am going to say that the 20 and the 50, I can divide those both by 10. So let's make that a 2 and that a 5. Next, the x to the 6th and the x squared, I could divide those just by subtracting exponents, and that's going to make this an x to the 4th. Finally, the x minus 2's are factors of both the top and the bottom, so I could divide those out and just get a times 1 there, really. And now that I've reduced everything I can, I'm just going to multiply across. So I have 2 times x to the 4th times 2 would be 4x to the 4th. And on the bottom, 7 times 5 is 35. And I'm done. So again, similar process. We're just reducing first. Once we've got factored form, reduce first, and then multiply what's left. In number 2, There's a couple of setup stages. First of all, it is division. So let me start by rewriting this as multiply by the reciprocal. And next, these are not in their factored forms right now, so there's nothing I can reduce yet. Let's get those factored forms. I'm going to factor out a 3 in the first numerator. Makes that 2x plus 5. And in the denominator, I have a difference of squares. 9 would be 3 times 3. And a minus x squared would be a plus x and a minus x. Second fraction. In the numerator, I'm going to factor out an x. Make that x minus 3. And the denominator with that a value that's not 1 is going to take just a little work. So again, I don't like to clutter up the main part of my problem. I'm just going to kind of come down to the bottom and make myself a little workspace. I'm looking for a sum of 4 and a product of negative 60. So it looks like 10 and negative 6 would do that. So I have the 4x squared. And I'll break that up as a positive 10x and a negative 6x. Minus 15. I can factor out 2x here. Gives me 2x plus 5. And let's factor out a negative 3 so that we also get 2x plus 5. And I've got 2x plus 5, common binomial, times 2x minus 3. And that'll go in the second denominator. All right, everything's factored. All multipliers now, meaning it's okay to divide things out and find the ones. I'm going to start by saying 2x plus 5 divided by 2x plus 5, that's definitely 1. And then I've also got this x minus 3 and 3 minus x. Those actually don't divide to 1. Remember what those divided to? Those divided to negative 1. So I can go ahead and say, let's divide them out, but I'm going to get a times negative 1 when I do. All right, I think that's about all I can do. So as I look at multiplying now, I have 3 times x times 1 times negative 1, or negative 3x. These, by the way, are over 1 if you like. And on the bottom, I have 3 plus x times 2x minus 3. Factored forms are so helpful that most of the time we don't bother actually multiplying those. We usually end up just leaving them in their factored form in the denominator and using this as our final answer. All right, let's try example 3. Lots and lots of factoring in these problems, but we'll get through it. Looks like the numerator here, I'm seeing perfect cubes again. So the cubes formula looked like this. And in this problem, a would be 2x. That's what got cubed to give the 8x to the third. And let's see, 27, it's 3 cubed, so b is 3. So the top of that first fraction, a minus b, would be 2x minus 3. And then a squared, squaring that would give me 4x to the second, plus a times b, that would be 6x, plus b squared would be 9. All right, the denominator. Looks like all we can do here is factor out an x, which makes that 6 minus x. Second fraction. I have the x minus 6 on top. I can throw some parentheses around it because we're really multiplying it by that whole fraction. And then the denominator, it looks like we're going to need to do a little bit of grouping here. So let's take this denominator the way it was written, and then factor the 4 terms by grouping. X squared times, whoops, not 2x minus 1, 2x minus 3 there. Plus, if I take out a 5, I also get 2x minus 3. So we've got 2x minus 3 times x squared plus 5. And that's this denominator. All right, I now look for places where I can divide some of these factors out. And I definitely see a 2x minus 3 divided by 2x minus 3. Those divide to 1. And I know you don't always remember to write the times 1. Obviously, it doesn't change the value, but I like to do it just to remind us what's going on here. We're really dividing and getting 1. Here, I have a division that's not 1, but negative 1, right? Subtraction, but with the order reversed. So I will divide those out, but I'm going to put a times negative 1 in. All right, so in the numerator, I've got this times negative 1. I could write that as negative 4x squared, negative 6x, and negative 9. I'm just distributing the negative 1. And on the bottom, I have x times x squared plus 5. Again, it wouldn't be wrong to distribute this in, but you're going to find when you check answers in backs of books or when you use MyMathLab to check your answer, almost all the time they're going to give that denominator in its factored form. So you might as well save yourselves that little extra work and just leave it like that. All right, one more. It's a division problem. And I'll start by just reminding you that when there's no denominator, automatically that's a denominator of 1. And therefore we can begin by doing the multiply by the reciprocal. All right, we got a little bit of factoring to do. It's a trinomial, but it's only 1x squared, so I know it's going to start with x times x. And let's see, this one would be a sum of negative 7, product of 6. So I'm thinking negative 1, negative 6. Denominator, again a trinomial with an a of 1, so it has to start with x times x again. This time a sum of negative 3, product of negative 18. think a negative 6, positive 3 would do that. Second fraction, numerator is just 1. In the denominator, I'm looking at a sum of negative 2, product of positive 1. Let's see, I start with x times x again. So here I'm thinking minus 1, minus 1. And I think we've got all of our factoring done. Now that we have factored forms, we can start dividing things out. X minus 1 divided by x minus 1 is 1. And x minus 6 divided by x minus 6 is also 1. So this time I only ended up with multipliers of positive 1. And in my numerator then, that's all I've got left. 1 times 1 times 1 is 1. Denominator, I have these two factors. I could multiply them out, but we usually choose to leave them in factored form. All right, so that is multiplying and dividing fractions, algebraic fractions. We'll look at adding and subtracting in the next video.